Dear students, welcome to my lecture videos on basic electrical engineering. In this class, we are going to discuss problems on self and mutual inductance concept. Last class we discussed about what is self and mutual inductance. Today we can discuss about problems on self as well as mutual inductance. Let us consider the problem. It goes like this: two identical coils of 1200 turns each are placed side by side such that 60% of the flux produced by one coil links the other. Full stop. A current of 10 amps in the first coil sets up a flux of 0.2 milliweber. Full stop. If the current in the first coil changes from plus 10 amps to minus 10 amps in 20 milliseconds, carefully observe the current in the coil because change in flux will responsible for the voltage. So therefore, the current in the first coil changes from plus 10 amps to minus 10 amps in 20 milliseconds. Find the values such as self-inductance of the coils. Second one, the EMFs induced in both the coil, that is primary as well as secondary coil. If we solve this problem, we can understand both the self-inductance as well as mutual inductance concept. Now I will take the solution. So two coils, so I will take two coils. I will write two coils. Okay, two coils are placed side by side. So each coil will have 1200 turns. So N1 is 1200, N2 is 1200 turns. Are placed side by side. Okay, condition is given. Observe 60% of the flux linking in the one coil produced by one coil links other. It means that whatever the flux produced in the pi 1 links to secondary is how much? 0.6 of pi 2. Okay, so whatever the flux links with the primary, in that 60% of the flux links with the secondary coil, and the current will changes how much? From plus 10 amps to minus 10 amps in 20 milliseconds. And current in first coil is I1, which is 10 amps, and it will establish a flux pi 1 is how much? 0.12 milliweber. So what is the amount of flux produced in primary? 0.12. So what is the amount of flux links with the secondary? What is flux pi 2? 60% of flux pi 2 is 60% of flux pi 1. Should carefully observe this condition is given. Okay, so time is given. The time is 20 milliseconds. Now we have to calculate the self inductances of the coil. We have to calculate L1 and L2. Both are same. Okay, now I will apply the formula. Now first I will consider self inductance of the coil L1 or L2. If you take anyone as first coil or second, okay, it remains same. So N1 N pi by I. If it is L1 N1, if it is L2 N2 pi 2 pi. Okay, now the data given is with respect to coil 1, so I will take it as N1, flux pi 1 and current I1. So what the turns given, number of turns given is 1200, that is N1, and what is the flux produced is 0.12 milliweber in coil 1. So 0.12 into 10 to the power of minus 3, and it will produce a current of how much? 10 amps. If you simplify, you will get L1 is equal to 0.0144 in 3. Okay, this is the value of inductance. Got it? Now I will go to next point, that is the EMF induced in both the coils, that is E1 as well as E2. E1 is self inductance, we know formula. So second option is EMF. So E1 is equal to minus L1 into di1 by dt. which is given by minus 0.0144. That is the value of inductance we have calculated. And what is the di1, rate of change of current? What is the current change? I is changing from how much? Plus 10 amps to minus 10 amps. So consider that. So the current will changes from 10 amps, okay, to minus 10 amps, plus 10 amps to minus 10 amps in what time? In 20 milliseconds. In 20 milliseconds. So what is E1? E1 is equal to minus 14.44 volts. Okay. Similarly, what is my mutual inductance? M. Now M is equal to, I will take M now, N2 into flux pi 12. What is that flux pi 12 is? The how much amount of flux produced in secondary coil due to rate of change of flux in first coil with respect to change in current in first coil. Okay, so which is given by N2 is same 1200. What is the amount of flux linking? 60% of the flux linking with the first coil. So 60% means 0.6 into how much flux produced in first coil is 0.12 into 10 to the power of minus 3. In the primary coil, whatever the flux produced, in that 60% is linking, that is 0.6. 100% means 1. So therefore, what is the current change? Current change is 10 amps. So I1 is 10. So simplify, you will get M is equal to 0.00864 Henry, or it is also we can write M is equal to 8.64 millihenry. 8.64 millihenry will be the M value. Now we can calculate now what is the EMF induced in second coil, that is E2 or E12. So obviously the EMF produced in the second coil is always less than the primary voltage, because the entire flux is not connected. Only how much flux is connected? Only 60% of the flux is connected. Hence we know the E2 value is 100% less than 14.4 volts. Only the 50-60% means almost half of the above voltage you are getting in the secondary. Okay, you will come to know how much. Okay, there is a one cross check, you can check it out carefully. Now what is my EMF produced in second coil is given by minus M into di1 by dt. So we already calculated what is M. 8.64 into 10 to the power of minus 3. Rate of change of current is, okay, 10 to minus 10 divided by 20 milliseconds. Simplify, the EMF induced in the second coil due to what is E12. E12 means the EMF into the second coil due to rate of change of flux in first coil. Okay, that is E12 is minus 8.64 volts. Obviously this volt is 8.64 is less than the 14.4 volts. What is E1? E1 is 14.4 volts. Okay, E2 is minus 8.64 volts. Okay, this is the voltage which is produced in secondary coil due to rate of change of flux in the first coil. So with this we can conclude this class. Thank you.